Hey, all, Brad here with another quick video. I had customer Dave send a complete Cenestar board set in, including the linear power supply. It was all original, wasn't working right, and so I stripped these completely down, almost nothing left on the board, just some of the discrete components like the resistors and some of the diodes and stuff. A lot gets replaced. All the Molex headers are new with the correct white Molex headers with the ramps. Socket the voltage regulators. I had a precision 10-turn potentiometer here to adjust the 5 volts. All the capacitors I buy from Arcade Parts and Repair from Peter over there, a complete kit, but they're all the electrolytics are new. As you can see, that heat sink here, this is the BR1, the 5 volt large bridge rectifier. I put this custom aftermarket heat sink on. I actually drill and tap it, and it looks very similar to the other one, so it really matches the theme, and it really helps dissipate the heat. This large rectifier is a real common failure. The one I put in here is rated for higher 50 amps, so the original one's much lower. It's the same dimensions. This is also for the 12 volt bridge rectifier here is new. The minus 5 volt rectifier here is new. I've also been adding a really cool little heat sink onto the minus 5 volt 7905 regulator here. So I add that. And back here on the heat sink, I had the customer send this in as well. I also go through and I take the end off and I put on a new end. I do put the polarizing key in so you can't plug it in wrong. And these are all the Trifurcon pins where they actually have little ramps that come out, so you're touching on not just the flat side back here, but the two sides also. And that's the other thing, going with these square pin Molex versus the original round, there's much more surface area you're making contact with. And then on the heatsink also, I obviously fully tested, clean it up, but I changed the silicone isolation pads here. They're very good at conducting the thermal heat out to dissipate it to the heatsink, but they're electrically isolating as well. So that gets through, tested. And then on my bench here, I've got it hooked up. You can see this harness on the output side. Comes up, I built a little rig, and this comes up here to my dual channel constant current DC load right here. So basically, I'll show you here. I'll power up my power supply here. And I also put these really cool high intensity green LEDs on. Everybody really likes those versus the red. I think if the green had been more readily available back in the 80s, the engineers obviously would have used them to indicate green is good. So you've got 5 volt, 12 volt, and your minus 5 here. And as you can see on the display, we're sitting roughly at about 5.1 on the 5 volts, and I'll show you why in a minute. 12.0 with no load on that system. So typically these boards for like Cenestar and Defender and Stargate and Joust and Robotron and all those, on the 5 volt side, they'll draw maybe an amp and a half, worst case, and on the 12 volts, typically they'll draw half amp. So what I do here is I've got these set. I can turn the outputs on for constant current, and I've adjusted the 5 volts for 3 amps and the 12 volts for 1 amp, which is pretty much double the normal running current. So if a failure is going to occur due to maybe one of the new parts had a manufacturing defect or something like that, they actually have a name. It's like infant death syndrome, right? The failure is really early on. If it makes it past that point, the chance of making it, for another 40 years is very high. So I let this run typically under this double the normal load for about 8 hours or so, and everything really, it heats up pretty good here. You dissipate a lot of heat. And then for the minus 5 volts, what I have here is just a fixed ohm high watt resistor, and I can turn on, you can see the little light turns on, and that's for the minus 5 volt. And it draws, these 7905s are rated at 1 amp, and I run like 0.8. They draw very little current on the game. Really, the minus 5 on these boards, the soundboard uses as a reference for the D to A converter over here, the digital to analog. And then on the MPUs over here, the 4116 uses the minus 5 as a reference voltage. It's not really consuming any current. It's more for a comparator circuit. So anyway, power supplies turned out beautiful. I crimped the fuse connections here. This thing gets stripped down, washed in simple green bath, baked, dried. Everything's new on it. Should last another 40 years. So thanks for watching.